So in the last class, we have discussed about the basics of DC to DC converter, why DC to DC converter is used, and the three types of that DC to DC converter. That is, one is buck converter, boost converter, and buck boost converter. Boost converter means output voltage will be greater than input voltage. That it is a step up converter. Buck converter means output voltage will be less than input voltage. That is a step down converter. And buck boost converter means either step up or step down converter. That is, it can convert either a low value of DC to high value of DC or high value of DC to low value of DC. Okay. And also we have seen the expression, that is duty cycle is defined as T on divided by T on plus T off, and T on plus T off means T. So D can written as T on divided by T, so that T on is equal to dt and T is equal to T on plus T off. Substituting T on is equal to dt here, we get T off is equal to 1 minus D into T. Okay, so these are things you keep in mind. And also next one is another two things you have to keep in mind is volt second balance and ampere second balance. I will tell what is this volt second balance and ampere second balance. So this circuit you have seen here, DC to DC converter circuit, that is input source Vs and a switch is there, and freewheeling diode for freewheeling diode for dissipating the charge energy stored in the inductor during the off time, and also capacitor C for reducing the ripple in output voltage, and inductor L for reducing the current harmonics. Okay, so volt second balance is defined as VL on, voltage across inductor at on into T on, plus voltage across inductor at off into T off, which is equal to 0. This is what volt second balance is defined about. VL into on means inductor voltage during turn on plus inductor voltage during turn off into T off, which is equal to 0. VL on into T on plus VL off into T off, which is equal to 0. What does it signifies? Average voltage across inductor will be equal to 0. Average voltage across this inductor will be equal to 0. Actually, during turn on, what will happen? This switch will be on. Due to this Vs, this inductor will be charged. Okay, and during turn off, what will happen? The switch will be on. So here no source is provided here. So this inductor will be discharging across this load. So charge stored during the turn on time, it will be completely discharging. What all the charge stored in the inductor during turn on time will be discharging during the turn off time. So energy stored in the inductor during turn on will be equal to energy discharged by the inductor during turn off. Okay, so during turn off, the switch is closed. So due to this Vs, the inductor will be charging, and during turn off, the switch is open. This freewheeling diode will become short circuited, and the inductor will reverse the polarity, and the charge stored in the inductor will be discharging across this load. Okay, so energy stored in the inductor during turn on, which will be equal to energy discharged during energy discharged by the inductor during turn off. So that is what this volt second balance signifies. VL into on into T on plus VL into off into T off, which is equal to 0. This equation you have to keep in mind. And another one is ampere second balance. Okay, here similarly, here we have taken the inductor, here we are taking the capacitor. That is, average current across the capacitor will be equal to 0. Average current across this capacitor current is there. Average current across this capacitor will be equal to 0. What is the purpose of this capacitor? To reduce the ripple voltage in the output. Okay, so here the average current across this capacitor will be equal to 0. That is IC on into T on plus IC off into T off, which will be equal to 0. This is ampere second law, ampere second balance law is about. Okay, so these two things you keep in mind: volt second balance and ampere second balance. Okay, and three we have seen buck converter, boost converter, and buck boost converter. Of this, first one is buck converter. Buck converter means output voltage will be less than input voltage. Okay, a DC to DC power converter which step down voltage while stepping up current. While stepping down voltage, it will be stepping up current. So, DC to DC power converter which steps down voltage from its input to its output or load. And the switch here used will be either MOSFET, BJT or IGBT. Okay, so the circuit for buck converter is same as that we have seen in the last classes. That is, a source is there, here switch is there, here inductor, here capacitor, and a freewheeling diode for discharging the inductor charge stored in the inductor during the turn off time. So inductor store energy while during turn on, and it will discharge energy during turn off. Okay, when switch is switch is on, the inductor will be storing charge due to this Vs, and when switch is off, the inductor will be discharging what all the charge stored during turn on through this load in this circular path. This freewheeling diode will become short circuit. It will be forward bias and it will become short circuit when turn off. Okay, and the capacitor reduce the ripple content in the output voltage. Here the main purpose of this capacitor is to reduce the ripple content in the output voltage, and free diode is present here. The freewheeling diode provides discharging path for the inductor during turn off. This freewheeling diode, main purpose of this freewheeling diode is to provide the discharging path for this inductor during turn off time. Okay, so when the switch is on, this equivalent circuit will be like this. When switch is on means this switch is short circuited, and the equivalent circuit will be like this. Vs, then inductor will be there, load will be here. So when switch is on, the supplied voltage Vs will charge the inductor. Vs will be charging the inductor. The inductor current will increase. Inductor current will increase as the charge increases. Current will increase linearly. The freewheeling diode will be reverse biased. Freewheeling diode, here freewheeling diode is there, it will be reverse biased, and inductor gets charged till the switch is on. Till the switch is on, the inductor will get charged. Okay, this is during when switch is on. Okay, and the capacitor placed here will be reducing the ripple voltage. And during turn on, inductor will charge from IL minimum to IL maximum, and during turn off time it will discharge from IL maximum to IL minimum. Here you see this is the turn on time, this is the turn off time, then turn on time, turn off time. Okay, so here in the last class we have seen that turn on time means which is equal to dt. So this time will be dt, and total time period is t. Okay, dt and t. Okay, and this is the inductor current. So it will be varying from IL minimum to IL maximum, then IL maximum to IL minimum, like that. So when inductor is charging means switch is when switch is closed during turn on time, it will be charging from IL minimum to IL maximum till this dt, 0 to dt, it will be charging from IL minimum to IL maximum. Okay, then turn off will come. Turn off will come means switch will be open. Inductor will be discharging the what all the charges stored in the inductor through the load. So during turn off time, that is from dt to t, inductor will be discharging from IL maximum to IL minimum. IL maximum, what all the charges stored in inductor during turn off, it will be discharged during the turn off time. Okay, then again it will be charging during turn on time, again it will be discharging during turn off time. That is what this graph represents. Okay, similarly this is the capacitor charge. It will be charging and it will be discharging, same like this. During turn on time it will be charging and then it will be discharging. Okay, and this is the VL, voltage across the inductor. During turn on time, what will be the voltage across inductor? During turn on time, what will be the voltage across inductor? Vs minus V0. Okay, Vs minus V0. And during turn off time, here this won't be there. What all the charges present in inductor, it will be V0. VL equal to V0 when turn off time. During turn off time, VL equal to V0. That is what shown in this graph. VL, IC, IL, and this is the turn on and turn off. Okay, that is what this graph signifies. Okay, so during turn on time, inductor will charge from IL minimum to IL maximum, and during turn off time, that is dt to t, it will be discharging from IL max to IL min. Then again it will be charging, again it will be discharging during turn on and turn off. And when switch is open, so here we have seen when switch is on, and when switch is open, what will happen here? Switch is open means this part is disconnected, this source is disconnected, and the inductor is charged. It will reverse the polarity and it will be discharging through this load, and this freewheeling diode will be forward bias and it will become short circuit. That is what shown here. This inductor will act as a current source. Okay, inductor will act as a current source. So source is removed from the circuit, so the charge inductor will start to discharge and it will be act as a current source with the reverse polarity. Okay, it will be discharging across like this. Okay, and the freewheeling diode will be short circuited and it discharges through the path shown in figure. Freewheeling diode will be short circuited and it will be discharging like this. Okay, so the inductor current will decay from IL max to IL minimum. In this graph, IL max to IL minimum, it will decay. Okay, so average inductor current, it will be between IL max and IL minimum. Okay, and delta IL will be the change in inductor current, that is rippling inductor current. Here you see, this is the change in inductor current. Change in inductor current means from IL minimum to IL maximum, that is delta IL. And the average inductor current, it will be in between this IL max and IL minimum. So this part you can written as IL delta IL by 2, and this part also you can written as delta IL by 2. This total is delta IL, ripple in inductor current, that is change in inductor current. Okay, that is delta IL. Okay, understood? Delta IL is the change in inductor current. And now when switch is on, this is the equivalent circuit. Here when we are applying KVL, VL on we can written as Vs minus V naught. Here when we are applying KVL, we can written as VL on when switch is on, VL on, which can written as Vs minus V naught. Okay, and also this Vc will be same as V naught because both are parallel, so the voltage across these two will be equal, Vc equal to V0. So here VL on we can written as Vs minus V0. This is equation number 1. And also IC on, here when we are applying KCL, IC on can be written as IL minus I0. Here this is incoming current and these two are outgoing current. IC and I0 will be outgoing current. So here when we are applying KCL in this loop, IC on will be equal to IL minus I0. This is equation number 2. Okay, when switch is on. Then so we got VL on and IC on. Okay, here. Okay. Then when switch is off, that source will be disconnected and the freewheeling diode will be short circuited. So the equivalent circuit will be like this: VL, then here IC will be flowing, IL will be flowing, I0 is there. Okay, so this will be the equivalent circuit when the switch is off. So applying KVL, when we are applying KVL, VL off, here only two voltages are there, VL off and V0. VL off plus V0, which will be equal to 0. So VL off we can written as minus V0, which is equal to equation number 3. Understood? Here VL plus V0 equal to 0. So VL off can be written as minus V0. And here applying KCL we can written as IC off, which will be equal to IL minus I0. Okay, IC off we can written as IL minus I0 because inductor will be discharging, so as current will be here, inductor current will be here, so it will be IL minus I0 when we are applying KCL at this point. Okay, so that is equation number 4. So from volt second balance, previously we have seen volt second balance. So what volt second balance states VL on into T on plus VL off into T off, which will be equal to 0. Substituting VL on and V off from 1 and 3. 1 means VL on is equal to Vs minus V0, and from 3 VL off is equal to minus V0. So instead of VL on, we are putting Vs minus V0. Vs minus V0 into T on means we have already seen T on is dt plus VL off is minus V0 into T off, we have seen in the last class 1 minus d into T, 1 minus d into T, which is equal to 0. Solving, we will get Vs into dt minus this, and this will be cancelling, and solving we will get V naught equal to Vs into d. V naught equal to Vs into d. Okay. Output voltage is equal to input voltage into d. And also this range of d means duty cycle. The range of duty cycle is in between 0 and 1. Maximum value of this duty cycle will be 1. Okay. So maximum voltage means in practical case only it will become 1. In ideal case only it will become 1. In practical case it will be always less than 1. So the output voltage will be always less than less than input voltage. Output voltage will be always less than input voltage. In practical case, output voltage will be always less than input voltage. That means, so this type of converter is known as step down converter or step down chopper. Here output voltage is less than input voltage. That is, input we are applying a voltage, output voltage is less than that. So it will be a step down chopper. Okay. So this is why it is called as buck converter. That is, in output voltage is less than input voltage. And also we have seen volt second balance. Now from ampere second balance, IC on into T on plus IC off into T off, which will be equal to 0. From 2 and 4. From 2 and 4, what is IC on? IL minus I0. Then IC off, IL minus I0. Both are same. So substituting here, IL minus I0 into dt plus IL minus I0 into 1 minus d. T of we can written as 1 minus d into t, which will be equal to 0. Solving, we will get IL equal to I0. That is average value of inductor current, which will be equal to load current. Average value of inductor current equals to load current in the case of buck converter. Okay. Average value of load current, which will be equal to average value of inductor current, which is equal to load current in case of buck converter. And also average value of output voltage will be equal to average value of input voltage into duty cycle. Okay, in the case of buck converter. And next, to find the ripple in inductor current. To find the ripple in inductor current during turn on, VL on is equal to Vs minus V0. We have already seen in equation number 1. During turn on, VL on equal to Vs minus V0. This VL on we can written as L into di on divided by dt. VL on can be written as L into di by dt. That is inductor. Inductor is charging now. Inductor is charging here. So L into di by dt. Okay, inductor is charging here. So this VL on can be written as L into di by dt. Okay, L into di on divided by dt, which is equal to Vs minus V0. And what is the change in current here? From that figure, what is the change in current? Change in inductor current you can see IL minimum to IL maximum, which is written as del IL. Okay, del IL. And during turn on means time period will be 0 to dt. Okay, during turn on time, how much change is happening in this inductor current? Del IL means IL minimum to IL maximum, that is del IL. And during turn on, time period is 0 to dt. Okay. So L into di on divided by dt, change in current during turn on, which is equal to del IL. From that figure we have seen it is del IL. And also time on time period is dt, 0 to dt. So it can be written as L into di on divided by dt can be written as L into del IL divided by dt, which is equal to Vs minus V0. Also V0 already we have seen V0 is equal to Vs into d. So substituting V0 equal to Vs into d, which is equal to Vs minus d into Vs. So del IL we will get as Vs into 1 minus d. Solving here, we will get del IL is equal to Vs into 1 minus d divided by L into dt. Here t can be written as 1 by f, means frequency. Inverse of frequency is time period. Okay. So t can be written as 1 by f. So del IL, which will be equal to d into 1 minus d divided by LF into Vs. This is the ripple or change in the inductor current. This is the change in the inductor current or ripple in the inductor current, which is equation number 7. And IL max will be equal to IL plus del IL by 2. That is from this equation. IL max, this is the change in inductor current. Okay, this is the change in del IL. So IL max will be equal to, this is the IL. Okay, this is the IL. So IL max we can written as, IL max can be written as IL plus del IL by 2. Okay, and also equation number 6 we have seen IL equal to I0. Okay, average value of load current will, which is equal to average value of inductor current, which is equal to load current. So IL max equal to I0 plus del IL by 2. Similarly, IL minimum is equal to IL plus del IL by 2. This is the IL. IL minus del IL by 2 is equal to IL minimum. And IL maximum will be IL plus del IL by 2. That is the IL maximum. And also we have seen IL is equal to I0 in case of buck converter. So this is the IL max and IL minimum for buck converter. And now for the output ripple voltage, del Vc or del V0, that we have to see. Output ripple voltage del Vc or del V0. We have seen that IC is equal to IL minus I0. Okay, during on time or off time, IC is equal to IL minus I0. Also we know charge Q is equal to CV. Charge Q is equal to CV. And also del Q is equal to, so change in charge, which is equal to C into del Vc. Okay, del Q we can written as C into del Vc. So del Vc we can written as del Q divided by C. When capacitor current is greater than 0, it is storing the charge. If the so the capacitor charge can find out from the shaded area in figure 1. Okay, here you see this is the capacitor current value. Here capacitor will be charging when the capacitor voltage is positive. So here the charge stored in the capacitor can be found out the shaded area, means shaded area will be positive area only, because if capacitor charge is negative means it won't count. So the stored charge in the capacitor we can found out from by seeing this shaded area. The shaded area, this is the T by 2 and this is the IL by 2. This so here it is a triangle, half into B into H we can take. So this is the base. Base is T by 2 and H is del IL divided by 2. Okay. So by taking the area, shaded area, we will get del Q is equal to half into del IL by 2 into T by 2. That is del IL divided by 8F. T we can written as 1 by F. So del Q we can written as del IL divided by 8F. Understood? Understood, no? That is charge of the capacitor. When capacitor current is greater than 0, it will be storing charge. When capacitor current is less than 0, it will not store charge. So here you see capacitor current is greater than 0 from here to here. So this shaded area, this means capacitor current is negative. So this capacitor current is positive means at that time only it will be storing charge. So that will be this shaded area and it resembles a triangle. So here the area will be area of this triangle. Area of triangle means half into b into h, half into base means t by 2, half into t by 2 into height means del il by 2, del il by 2. So here we will get the store charge in that capacitor del q, which will be equal to half into del il by 2 into t by 2, which is equal to del il divided by 8f, del il divided by 8f. Okay, and also del q is equal to del il divided by 8f. Already we have seen from 7 that del il equal to d into 1 minus d into lf into vs. Okay, d into 1 minus d into vs divided by lf, that is del il. So and also del vc equal to del q divided by c, del vc equal to del q divided by c, all are substitution only. Del q divided by c, del q we know that del il divided by 8fc. So this equation will become del vc equal to del il into 8fc. So substituting del il here, what will get? Del vc equal to d into 1 minus d into vs divided by 8f square lc. This is the ripple or change in the capacitor or output voltage. This is the ripple or change in the capacitor or output voltage. That is the expression for ripple or change in the capacitor voltage or output voltage. That is this expression. And here when d is equal to 0.5, the ripple in the capacitor voltage and the ripple in the inductor current will be maximum. When d, if we are giving d is equal to 0.5 in del il or del vc, the ripple in capacitor voltage or ripple in the inductor current will be maximum. So these all are things about buck converter. These all things we have seen for buck converter. That is, what all things we have derived. One is output voltage which is equal to Vs into D. So by changing the duty cycle, we can vary the output voltage, and the output voltage will be always less than input voltage. That is one. Then another one is that average value of inductor current, we got it as load current. Average value of inductor current is equal to load current in case of buck converter. Okay, and also del IL we get as change in ripple in inductor current, we got as d into 1 minus d into Vs divided by Lf. And if we are substituting d, that duty cycle, as 0.5, this change in inductor current will be maximum. So del IL will be maximum when ripple is del IL will be maximum when duty cycle is 0.5. Okay, then similarly IL max we got, IL minimum we got. Then finally the change in or ripple in output current or capacitor, ripple in output voltage or capacitor voltage, we got it as del Vc, which is equal to d into 1 minus d into Vs divided by 8f square Lc. So when we put duty cycle equal to 0.5, we will get maximum ripple in the capacitor output capacitor voltage or the output voltage. So this is about the buck converter. Main thing with buck converter is it will be stepping down the voltage, that output voltage will be less than input voltage. So this is about buck converter. Okay.